Hash include, as I mentioned just a moment ago, is a directive for the C preprocessor. Whenever you encounter a line in the code that says hash include some file name, that line of code is removed from the .c file, and the C preprocessor goes and finds the included file that usually ends in .h and substitutes that one line, that hash include line, for the entire contents of the included file. Here is, of course, that example. Could be filename.h. So all the contents of filename.h will be copied and essentially pasted in place of the line that reads hash include filename.h. Filename.h and all the other files that end in .h are known as header files. That's just their name, the name that programmers give them. Some programmers also refer to them as include files for obvious reasons. Now, the header files will hopefully be found in one of the folders specified in the compiler's include path. Now, you probably don't know what a compiler's include path is, so I will describe it to you. You make a line of code in your program called hash include filename.h. Now, the compiler will go, oh, where's filename.h? I hope I know where that is. Previously, hopefully, the compiler will have been configured such that it knows where to look for files ending in .h. There is a sequence of directories or folders that the compiler will look in order to try and find filename.h. And there could be one folder or directory in this path or in this list, or there could be a dozen, well, a dozen is somewhat unlikely. There usually is only about 4 or 5 different directories where it goes to look for filename.h. This list of directories that it looks through in order to find header files is known as the include path. I'm going to show you the include path for the dev C++ compiler in just a moment. So what happens as soon as the preprocessor sees hash include, it says, okay, well, I've got to look for that particular header file in my list of include folders or include directories. So it looks through each of them in turn, starting at the top of the list until it finds the filename.h. And if it gets to the end of the list and it still hasn't found filename.h, you get an error message from the compiler. Well, it'll actually be from the C preprocessor. There is a slightly different version of the hash include directive which looks like this. Hash include filename.h. Now notice the only difference is that instead of the what we call the angle brackets, the greater than sign and the less than sign, we have the double quotes. Now the only difference between that and the first one is that if the C preprocessor reads that line, the first place it looks to try and find filename.h is the current directory, the directory where the current .c file is. It'll look there first, and if it doesn't find it there, then it will go off and look along the include path list. Now, why would you need that? Why would that option be necessary? Why would you need to have 2 separate versions? Why not just have one or the other? Obviously, the one with the quotes on it is more powerful because it looks in more places. Well, the answer is that you may actually want to specify, for example, you might want to set up your own stdio.h. You might want to write your own one that's different from the other one. And sometimes you might want to use the standard C library one, and sometimes you might want to use your own one. So you've got to be able to choose between them. And that's one of the reasons why. So in other words, filename.h should be found in the current folder then, hopefully. Okay, now let's just have a quick talk about header files and what you will typically find in a header file before we actually go and look at some code examples. Header files. Okay, you've looked at the hash include directive. We know what it does. It's a bit of text substitution. But that doesn't really tell us what is the code you'll find in a header file that will end up being put into your .c file. Well, header files, or .h files, or include files, depending on what you want to call them, contain source code that needs to be shared between 2 or more .c files. What does that mean? Well, as I'm sure you can probably imagine, a given C project, a system that's being developed in C, will contain more than one .c file. in fact, is most likely to, if it's an industrial package, might contain hundreds of .c files. And each of those .c files might need to know some certain piece of information, such as, well, let's think back to an example that we've already had. Remember stdin? When I do an f-flush, I do an f-flush of stdin, and the definition of stdin comes from stdio.h. Don't know if you remember me saying that, but I did say that. So let's think about what I just said. The definition of the term stdin comes from that header file. Now, I could have just as easily, well, if I knew what it was, I could write the definition of stdin directly into my .c file and not worry about the .h file at all. That's entirely possible. If I could be bothered doing that, and if I knew what it was, it might save me the trouble of having to have a .h file at all. But when you think about it, if you've got, let's say, 100 different .c files that all go to make up one system, you really don't want to be writing the definition of stdin out 100 different times and putting one definition inside each .c file. That would be a lot of work, especially if down the path a bit, the definition of stdin actually changed. So instead, you define it in one place, one single place. You put it in a .h file, and then you simply put the line #include stdio.h into all your .c files, and thus the definition is only created by you once. It's much less work, especially if the definition ever changes, because then you just need to go to the .h file, change the definition of stdin, recompile all your files, and it's all fixed. You don't need to go and touch each individual file at all. Just so that you know, a header file obviously is going to be included in your .c file by the use of a #include directive. Now, actually, you'll find that header files can also have #include directives in them. So you can have a file included inside a file that is then included inside another file, and so on, as deep as you want to go. It can get a little unwieldy, and some people strongly recommend that you don't even go down this road at all, but I'm not one of those people. I think if you do it intelligently, you can actually make life a lot easier for yourself. But you'll discover that for yourself as you develop larger and larger scale projects. Anyway, I just wanted you to know that you can do that. That it is possible to do that. Okay, what else? You can create your own header files. You've got a bunch of header files that have been created for you and provided by the compiler with the standard C library, such as stdio.h, string.h. Those are, I think, the only two that you've seen so far. You can create your own. As I suggested just a moment ago, if you had a big project of 100 .c files and you wanted to create some kind of definition that needed to be shared between all those files, you would then, the steps involved would be to create a .h file, if you needed to, and put your definition in that. Okay, what else do we need to know about header files? Well, this is quite important. What do you find in a header file? Header files never contain code that causes machine code to be generated. What does that mean? Well, you'll never find code in an include file that reads something like, int x equals 5, y equals x minus 3. Those are what I'm talking about when I say machine code gets generated. Instructions, steps that the program can follow when it's running. X equals y minus 3 or something like that. That is an assignment statement. There's a bit of addition happening or subtraction and then an assignment statement. That should never go into a header file. Well, not unless you're just trying to prove a point. It can go into a header file, but I strongly recommend against it. So what sort of things can go into header files? Well, you can put in other preprocessor directives, including #include, such as, well, all the other ones that you're going to see in this chapter: #define, #def, #ifdef, #if, #endif, and a few others that you'll see. Those are quite okay to go into header files. Also, global variable declarations, including extern variable declarations. You don't know what those are yet. In fact, most of the things that go into header files, you don't know what they are yet, which is why I haven't shown them to you yet, because we really haven't seen what header files are all about. I didn't want to show you all these things before I could show you where to put them, in other words, into a header file. We can also have structure, enum, and type def definitions. Again, you don't know what those are, but you will shortly. Function prototypes, again, you don't know what those are. that all these things should go into header files and comments. Well, you do know what comments are, and you can quite easily put a comment into a header file. All these 5 different points here have something in common. They're definitions. Well, comments aren't really definitions, I guess, but comments aren't really counted as anything as far as code is concerned, but the other 4 are all definitions. They don't actually contain code that will be generated. They simply define items that will be used in code that is generated in your .c file. Let's think of a concrete example here. Remember the old function printf or scanf? You may recall back in an early chapter I told you that if you ever use printf or scanf, or for that matter fgetS or fflush or stdin or studout or any of those things, then you should put the line of code into your .c file that reads #include stdio.h. Now the reason for that is that stdio.h contains the definitions of all those things. It contains the definition, well, almost I guess the definition of the function printf and scanf and fgetS. Now, I don't want you to think that somehow those functions have been written inside the .h files. Obviously, there is a standard C library function somewhere called printf, and knowing what I know about printf, it's probably a couple of thousand lines of code. It's quite a complex function. Now, I don't want you to think that if you include studio.h into your .c file, that you're going to get 2,000 lines of code included in your .c file. You don't. You'll find out more about that when we talk about libraries. But what you will find is that the definition of printf is included. So the definition of printf is just a single line of code that says this is what printf is, and this is what it looks like, and this is what it returns to you, and these are the parameters it takes. Now that's called a function prototype, and you don't know what that is yet, but you'll see one soon. One of those is included for printf, and another one for scanf, and another one for fgetS, and another one for putS, and another one, and so on and so on. And there are actually probably, I'm guessing in studio.h, there's probably about 50 of them. So you've got 50 lines of code there. You don't have 50 lots of several hundred lines of code, each of them being the function itself. You just have the declaration or the prototype for the function. Again, this will make sense later on in a later chapter. So you might ask yourself, well, where are the actual functions? Where are those 2,000 lines of code? Well, they're sitting off in a library, and they get added to your program during the linking phase of the compilation, which we will talk about in the next chapter. We'll talk about linking at that point. So you might be looking at that list on this page at the moment and say to yourself, well, there's really nothing that I can put in a header file at the moment because I don't know what any of those things are. And that's correct, you don't. But you will over the coming chapters, and I wanted to show you header files now so that when you do learn what those things are, you know where to put them. In fact, we're going to start looking at some of those things immediately. The other preprocessor directives, the first of those 5 points, we're going to learn about those right now. Before we do, I'm going to go and show you some concrete examples of how to use #include. I know that you've kind of seen them before, but it might be worth doing a bit of recap. Let's look at the source code. Okay, I've called this file include.c, and it's a very simple file along the style of our other very simple files. Please enter your name, then we'll work out the length of that name, and then we'll print out the name and its length. Okay, pretty simple. Now, look, this program will not compile, and I'll prove that to you. Okay, we've got some errors here. Stdin undeclared. Okay, where's stdin? Let's have a look. There's stdin. Okay, that is undeclared. The compiler does not know the definition of stdin, and that's fair enough, because where could it possibly get that from? So, as we know from before, we put #include stdio.h. Notice that it is inside angle brackets, which means the compiler is instructed to look all along the list of directories that make up our include path in order to find studio.h. So let's see if it compiles now that that line has been put in. And now we have 0 errors. Okay, so that's much better. That proves to you that studio.h is going to make a difference to our successful compilation of our file. Now this file also uses strlen. Strlen is a function. We know that strlen is a function, and it returns the length of a particular string. Now, the definition of strlen, the prototype for strlen, can be found in string.h. So why did the compiler let us get away with not having the definition of strlen included, in other words string.h, but it didn't let us get away with stdin? And the answer is that strlen is a function and stdin isn't. Well, that's only the gross part of the answer. The real answer is that the only thing that refers to strlen in string.h is the prototype, and prototypes in C are optional. You don't have to have them. There is a prototype for strlen in string.h, but because it's optional, the compiler did not complain to us when it didn't find the prototype for strlen. However, stdin is not a function. It's an actual, well, you can think of it as a variable. And as such, it must be declared. It's not a prototype now we're talking about, it's an actual declaration of a variable. You can call it a global variable if you like. And it's not optional whether you declare or don't declare a global variable. It's absolutely mandatory. So that's why the compiler did complain about not having the definition of that present, but it did not complain about not having a prototype for that present. Prototypes are optional. Okay, so now where does the compiler go to look for those two files? Well, let's see if we can find out where it goes to look for them. I know where to look to find out that list. It is in compiler options. Now, here is the compiler options. The C include files can be found in that, all of them can be found in that directory or that folder. So it's not much of a list because it's only got one directory in it, but it is quite possible to put a semicolon on there and put another directory. I'll try that again. So we could here say perhaps C:\directory and so on. And then I could put maybe another semicolon and C:\dir2 and so on and so on and so on. That constitutes the list. It's a bunch of directory names separated by semicolons. Well, it is in this program anyway. In Unix, the directory names are usually separated by colons, so it's different for every compiler. But the list is, there is always a list. For every compiler has somewhere a definition of where the include files can be found. And you can add your own. You can say, add the following directories. And so you can add them here or you can add them here. It's completely up to you, apparently, in this particular program. Alright, well, I'll just get rid of those. Well, you might be interested to actually have a look at stdio.h or string.h. So let's go and have a look at it. I'm going to go and find it now and open it up for you. Okay, so I'll just cancel that. Okay, I'll just pause this while I go off and hunt it down myself. Okay, I found it. Here we are, stdio.h. All stdio.h's are different for every compiler. So don't think that your one is going to be exactly the same as this, although it is probably going to be very, very similar. And this is what it looks like. Did you expect it to look like this? Let's see if we can find stdin. Stdin has to be in here somewhere. I'll scroll down until I find it. Oh, there it is. Stdin. Now, you don't know what the words hash define mean, but you're going to find out what they mean in a moment. Stdin, and there's also stood out, and there's even a third one called stderr, standard error, and so on. Let's see, what else have we got? We got a printf, there's printf, and we've probably got a scanf somewhere, there's scanf, and we've got an fgetS. It's always very nice to read through these files and find out just what's at your disposal. It doesn't necessarily tell you what they are or what they do or how to use them, but you can look them up in your, hopefully in your reference library. And you probably will have one of those. And as you can see, it's quite long. In fact, if you look down here, it says there are 379 lines in this file. So when you go hash include stdio.h, all 379 lines in stdio.h are copied and pasted into your file, and then your file is compiled. Did you know that? Okay, well, you know now. And then you get to the end. Okay, so that's what stdio.h looks like. Okay, so let's move on now. In the next module, I'm going to show you what all these hash-defined things are. So hopefully a lot of this will start to make more sense.